Hi everyone. Myself Anvita from DataMites, and in this video we will be looking at the topic SQL. So SQL stands for Structured Query Language, and we will be looking at what it is in a bit. But before we look at what is structured query language, we need to look at what is structured data, or rather first before what is data. So data is effectively any information that you store, any raw information that is recorded. And earlier, how people used to do it is, let's say, record data in files or books, then it moved to recording the data, let's say, phone numbers, age, birth date, death date on a computer or on secondary storage devices. Okay, so let's say CDs, DVDs, pen drives, and all of these have a certain capacity, a certain storage capacity. And now that we have moved to big data, we are generating more and more data each day. So we have different ways of storing this data, right? So whether it is just data or big data, and the difference is the speed at which we are generating or the volume of data that is generated, right? So when it is big data, there is a large volume and it is generated at a much higher speed, and we need much more compute capacity to process and store this kind of data. So whenever any data is generated, let's say it is medical records, okay? And let's say there are patient names, there is an ID, they would have certain reports coming in, maybe the doctor that is seeing them, right? And there can be more values. So let's say this is patient 1, 2, and 3. Okay, they will have a certain name. Let's say they have IDs. You will have different reports. Let's say these are images, okay, .jpg files, and so on. Okay, so now this can be an example of how the data is looking like. So when data is coming in, of course, we need to store it somewhere, and then we move on to either processing or analytics based on what our problem statement is and what we want to find or infer from that data, right? So let's look at how do we store or organize or collect our data. Okay. So before we process or analyze it, of course, we need to store our data, and an organized collection where we store our data is called a database, right? So database is nothing but an organized collection of data, right? So let's say you have a hospital database for medical records. You may have a university database. It would have student data. It will also have teacher data. It may have data about courses, right? And how do we organize this collection of data that is coming in that we will see? Okay, so data may be structured, it may be unstructured, and it may also be semi-structured. So what do these terms mean? When there is structured data, it means that you would have a row column format to your data. It would look like a 2D table, and the relationship between the data points are defined. Okay, so that is why it is also known as relational data. Okay, so relational or structured data, whenever you see these terms, you would imagine a table where it is stored, right? So let's say if this is student table, it would have student ID, and the data types of these columns will be defined. So it will have student ID, let's say that has type integer. It may have name, it may have location, and let's say it has student marks. Okay, and we will shortly see what are data types. So let's say, for example, if they have these data types, what it essentially means is we will exactly know what are the columns present and what are the types of data present in this table, right? So if we know all of these things and also know the relation between certain tables, let's say the relation between student table and the relation between teacher table in the same database. So this is how we will organize and store the data in tables, and those tables will be present in a database. So basically you would have logical categories, right? So for structured data or relational data, you will have a relational database. So we will be moving into unstructured and non-relational when we come to it. And first we will look at relational databases. Okay. Now to manage a database, which effectively looks like there will be tables, and tables will be present inside a database, right? To manage this data that is stored in these tables, we need a management system, which is known as a database management system. So for relational or structured data that would be visualized in the form of tables or stored in the form of tables, you will have relational database management systems, right? So let's go ahead and look at some relational database management systems. So as you can see, database will be an organized collection, right? This is the logo that will represent your database. Whether you are working on any database management system, you will see this logo, the cylindrical logo. It will represent a database, right? It has a logical category. For example, if it's a university database, it may not contain medical records or product data. It will contain the data that is related to students, faculty, courses, staff, etc. And to manage this database, you would need a database management system, right? You will be allowed to create data, insert data, which is also called reading data, right? Update certain records if there is an entry that is not suitable or that is wrong. Okay, delete data if you have, let's say, old data present that you don't need anymore, or if certain things are incorrect or null that you need to drop. Also, if you have repeated data. So all of these operations we are going to see when we do it on an actual database management system. So nothing to worry about. We'll be seeing it in the next few videos, right? And you can see on your screen there are certain database management systems listed. So some of these are relational and some of these are non-relational, which is for unstructured data. Okay. So MySQL is one of the relational database management systems, and MySQL is the one that we'll be seeing to run our SQL queries, right? So let's look at why do we need a database management system. So of course, let me quickly annotate this screen. So of course, we need to store our data first before we process it. So storage is one. Abstraction means hiding unnecessary, let's say, codes or details that you wouldn't need to know. Let's say you would give a command. You would give a command to execute a certain operation. Let's say you want to find the average sales in a shop. So you will give the command to find it, but you will not necessarily know all of the things that is happening inside the database. And you wouldn't need to know it because you only need to know how to give the command and how the command is going to execute. You may need to know a little bit of that, but not exactly everything that is going on. So that makes it more user friendly, and more users can collaborate and use database management systems with the help of abstraction, right? Also, if you're sharing that data with someone and sharing the commands that they need to run, you can abstract your important functions so that they don't know how you are doing it, right? Redundancy means repetition of data. So if there is certain repeated data, let's say there is duplicate records, they need not be medical. This is just an example.